All right, question number 8. We have 7 parts. It says use n equals 10, probability of success 0.8. We're going to complete parts A through D. So we can do this with the StatCrunch app or the table. So I'll show you how to use the table. So I'm already on the page that shows 10 number of trials and 80 as the chance of success. Now what you will notice on the table, 0 at the top, it doesn't show, but this first row is 0. As I go across, when I get higher and higher percent, when I get to 0.65, there's nothing here for 0. So what that means is that the probability of 0 successes is so low, it's basically 0 when rounded to 4 decimal places. So when I get over here to 80, there's nothing in 0, there's nothing in 2, and then the first probability we get is on the line where there are 0 and 1. When I get to 2, that's the first line that I have a probability. So we can verify and confirm that with the Stat app, but I'll probably use this table under 80%, and then for 0 and 1, we'll do 0, and then we'll do 2, 3, 4, 5, 6, 7, 8, 9, and 10 will be our remaining probabilities. Okay, so let me just show. Get more help, StatCrunch. If we do stat, calculators, binomial, we're going to do 10, 80% equal to, we're doing exact probabilities, and we want to do 0. So you see 0, you got 1, 2, 3, 4, 5. It won't round to anything. And if I do 1, we get 1, 2, 3, 4, 5 zeros again. So when we round to 4 decimal places, we're not getting anything for those first 2. And then we get 0.0001 on the next one, and then we get 0.0014. And then the next one we get 0.0090. Looking at the correct column. No, 001. I jumped off the wrong column. 001 and then 0008. Looking at this column, 80%, and then 55. Jumped over 2 columns. And then 2064 or 0264, 0264. And then we get 0881, and then 2013, extra down in there, 2013, 3020, 2684, and then 1074. All right. Part 2, it says compute the mean and standard deviation of the random variable using the formula. So with binomial, the mean is equal to n times p. Now they want you to do it with number times probability, but you should get approximately the same. I'm sorry, I wrote down n times p, we couldn't see it. So mean is equal to n times p. So the number of trials times success. So if we just do 10 times 0.8, that'll give us 8. Now let's do it. I'm also going to do it with the calculator, but I'll type in all of these. Actually, I think I can get it to output all of these at once. No. Let's just type it all in. So if we do 0 plus 0 plus 0.0001, sorry, let me clear this out. We got to do this times the probability. So the first two will be 0 when I add 0 times 0 and 1 times 0. So I'll go ahead and do 0 and 0. You don't really need them, but just for the sake of argument, 2 times 0.0001 plus 3 times 0.0008 plus 4 times 0.0055 plus 5 times 0.0264 plus 6 times 0.0881 plus 7 times 0.2013 plus 8 times 0.3020 plus 9 times 0.2684 plus 10 times 0.1074. All right, so you definitely want to double check because there's a lot of data entry right there to make sure you got it all in there correctly. 3020, that's fine. 2013 and 7, right, 1 and 6. Okay, so I think we got them all in there. If I hit enter, got an error, so let me see what syntax error. So I got another dot in there instead of a 0. So compute, and we get 7.99999 when we round to 2 decimal places. 9 will round up and carry over, so we will end up with 8. Okay, which is the same thing we would have got if we just do n times p. And then standard deviation is n times p times 1 minus p, or q, and you do the square root of that. Okay, so instead of doing with the formula, now that we have a distribution, let's just go ahead and do it with the formula. So we're going to do the square root of 10 times 0.8, and this will be times 0.2. I'm going to do the square root of that. Second, square root 10 times 0.8 times 0.2. And we get rounded to 2 decimal places, 1.26, and that will not round up. All right, we're going to compute the mean using the mean formula, so you're going to get basically the same thing. They just want you to show you that they're the same. So we got 8, which that's what we did the first time. And same thing, if we did it with the standard deviation formula, it would be equal to 1.26 when rounded. So they just want you to know that the previous formula we used will work for distribution as well. Number 6, we want to draw the graph of the probability distribution and comment on the shape. So we talked about in the text, when you have a high probability, it's going to be skewed to the left. So if we were to draw this graph, you see how it's low, 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 and they're all low probabilities, and they're slowly increasing and getting higher. So that tells you you're going to have a trend that's going to be low, and it's going to tick up and then go back down. So B is the one that would match, especially if you were to try to trace and draw those lines up. And then the binomial distribution is skewed to the left, low tail.